Hello ladies and gentlemen. Right, what we have here is a project that I've been working on for 3 or 4 years now, which primarily is to optimize Zarch so that it will run at a static 25 frames per second on the original 8 MHz ARM2 that was in the A305 and A310 Archimedes. Well, I suspect that's not the reason you're here. You're probably here to see this. So, as you can see, it's an expanded landscape. The original Zarch was 6 blocks by 9. This, what you can see here, is 48 across by 32 deep, plus an additional 4 plotted it out into the front. The reason I've done that is so that it fills the bottom of the screen, because a lot of the time it didn't get anywhere near the bottom of the screen, original Zarch routine. And the reason it's taken so long to get to the point where I can actually demonstrate this is that it was really hard, really difficult to get it stable enough to actually run. In fact, I was working up to about 10 o'clock last night trying to get it to even get past level 3, where it would just crash. And I think I've sorted out all the stability issues. The reason there was such an issue is that the original code intermixes data and code, and not only that, there are tables that are constructed within the game whilst it's building up the plot, the landscapes and triangles. They're mixed within the code, so to be able to plot additional landscape, I've had to extend those tables, which has meant moving them. Trouble there is that there was just so many redirected pointers, hundreds, literally hundreds of them, and not only that, there's ADRs within the code, and even worse, there's pointers to pointers. So it was, it took forever, took years. Right, let's just get out this demo mode. I'll just put it back into self-play. Right, in case you don't know, there is a cheat in Zarch. If you do Q, R and U all at the same time, or slightly one after the other, do it myself, then you can actually turn on demo mode, which is what this is now doing. Right, so let's discuss the issues first. Now, as you can see, the landscape doesn't graduate into the back to black very well. And the reason for that is that the palette on the Archimedes isn't, well, sorry, I should say the palette on the original vid-C that's in the original Archimedes, you couldn't actually define every single bit within the palette. On 2x6 colour palettes, certain bits were fixed, which gave you what they call tints. So there's every colour you can define, there are 4 tints of it. Which also restricts the amount of colours that you can define. And the problem there is that with the default palette, it doesn't actually fade to black very well. It fades down to near dark, or near black I should say, and then it switches to, well, the nearest colour is grayscale, which is why you can see in the distance here that the colours suddenly give way to grey. Now, I did have a go at redefining the palette to get a better graduation to black, but then that just messed up the foreground colours, particularly white, because you just lost instead of losing, well, you lost all the dark shades of grey on the colours and gained them, but you end up losing the bright colours, so there were no shades of bright white, which white isn't used too much in the game. But it did affect the landing pad. It looked quite bad, so I just stuck with the original palette in the end, which is what you can see here. So that was the issues. The other thing I've done here, this is also running on a Pi 3. To get it to look stable like this, I've had to triple buffer it. I did on whether to triple buffer it or to double buffer and swap around the VSync and the frame swap, but in the end I decided to triple buffer it. So that there are still some issues to sort out there. You'll notice that when it completes a level, if it gains an extra life, or even if I add a life now, then you see the screen jitters. The reason for that is that it's switching to the wrong frame buffer when it plots the extra ship up the top. It has to plot it on all 3 buffers, and obviously that means you're going to see well, it should do in the background, but obviously I've got an issue to fix there, but anyways, it's no biggie. It just means sometimes when you finish the level it doesn't actually display the high score. Right, so to get this far, I'll just quit out of the game for a second. Wrong thing. I'll go into it. So this is the source code. So what I've done is, actually this is basic. In fact, I'll just change this to base ASM so I can see it a bit easier. So what I've done is go through and label everything. There's quite a lot labelled here. This is the link tables I was telling you about. There's a link there to table 8. So there's 2 links to it, and there'll be other links elsewhere. I've gone through labelled variables, all these tables. I've no idea what half these tables do. I've worked out what some of the code does. I've done that by painstakingly knopping out the code, well, exiting the code early, and then seeing what effect it had on the game. And from that, I've managed to work out what some of it does. There's a large chunk here of stuff I have no idea what it does. But essentially, I've done all the key routines. So, for example, the plot triangle. So this is the triangle routine. I've worked out what the inputs are, and what can be corrupted. The triangle routine that Zarch has in it isn't particularly optimized. First thing it does is it does it does clipping there, decides whether to clip or not, and then it does a sort of the triangle points in Y order, I believe, from top to bottom of the screen, so you can plot going down the screen. And from that it then starts building up, which is what all this does, building up the extra triangle line plots and then calling the plot routine. The quadrilateral routine, however, calls, as you see here, calls the triangle routine twice. So that's not particularly optimal. As I can show you here, this is the thread on stardot regarding all this, somewhere here. I have actually put here we go. Right, so this is an analysis I did on a recording. How many did I record? Right, so recorded 16,500 triangles. So I recorded Zarch playing and recorded all the triangles and quadrilaterals that it plotted. And then from that I've worked out, so this graph is showing you the average length of the actual width of the triangles. The reason for that was to work out the most optimal way of actually calculating the vectors, whether to do it through a multiple instruction, or whether to use a reciprocal table. I've then gone and broken down those triangles into line fills, and as you can see here, the 261,000 1-pixel plots are done on the triangle routine. So anything below, is that 3 pixels? 50% of the plots, pretty much, well no, probably about 33% of the plots are all being done on very short length lines. And the reason for that, I show further down. I'll just skip to the next page. Right, here you go. So this is the same, that original graph. Again, now this is showing you line fill lengths using triangles, and this is the line fill lengths if you switch it to a quadrilateral routine. And the reason there's such a marked difference, you see the majority of line fill lengths here are between 16 and say 18 pixels, whereas if you look at that same region here, there to there, there's very few in the grand scheme of things plotted there. Now the reason for that is that where you're plotting a quadrilateral, if you've got the two quadrilaterals meeting at a fine point, then you can end up with a lot of very thin lines on two triangles, so you end up just exacerbating the problem. So I did a lot of optimization, a lot of analysis here to see okay, what would happen if we switched it to a true quadrilateral routine, which is what the green line is, and then the triangle line length count comes down from, well, certainly the small length line fills, 261,000 down to 24,000. So it's a substantial saving in CPU cycles there. Now, if I go down further, I've actually started to do some analysis on where within the 16 quad word memory boundary the line fills actually are. And the reason this makes such a difference is that with MEMC, there's a trick you can use where if you do your writes at a particular point within the quad fill, then you can actually gain back one cycle. And that doesn't sound like a lot in the grand scheme of things, but if you once you add it up over, well, 687,000 line fills, that's quite a lot of cycles you can get back potentially. So I analysed, which is what the graph is showing, where within the 16 bytes within the quad word the bulk of the fills were, and then somewhere further down, the next page probably, I've actually then started looking in detail at optimization. Might be the next page. That's what Zarch might have looked like. I have no idea how they got those shades. I can only think that the palette was substantially different on the original Archimedes. But then it's hard to tell because that's a shot of a monitor. But it does look like all it's done is double the depth and then it's faded to red rather than to grey. But as I say, it's hard to tell on that. Right, where was I? There's the palettes I was looking at instantly. That's the default Archimedes palette, which looks like that. And then that was the optimised one, which as you can see here, you do actually get shades to black. But as you see, it completely messes up the bright whites. Right, where are we? Right, must be next page. You see, it's quite a long thread. It's gone on over a number of days. Oh, here we go. Right, so what I've done here is I've analysed the cost in time to actually plot line lengths within the quad word. So you've got the quad word offset going into the graph, and you've got the line length going across. So that graph is showing if the line fill routine is using 4 registers to store the colour to plot it, and this graph is a fallback in case I couldn't allocate enough registers. It's just using 1 register to do the line fill. You see, there's not a massive difference. But it is a good 20% slower. There we go, 22%. So it's 22% quicker if we can use 4 words instead of just 1. So anyway, that's what I'm aiming for. And just as a comparison, so that's the new line fill routine. That's Zarch's original routine. So the slowest Zarch gets is 18,000 nanoseconds, and the slowest we get on 4 is, well, just over 6,000. So it's near enough triple the speed. Right, anyway, going back to the code. So the idea is that rather than calling triangle routine twice, there will be a quadrilateral routine. Now, I did actually post that in here somewhere. I wrote it in BASIC. Where is it? In fact, I think it's right at the very end. Go to the last post. There we go. Right, so oh no, that's not it. That's the original assignments. Bear with me. It's this one here. Right, so this is the proposed quadrilateral routine, which I've written, you see, in BASIC. The reason I wrote it in BASIC was so that I could work out the best way of avoiding having to sort. And so what I've done here is it does. If I can find the first routine, here you go. So this checks to see if first, the second, and the last y coordinates in the plot are a certain order, and if they are, it'll hit those first. So that catches 80% of all plots. So I've gone through the whole code and structured it all based on the amount of times it's hit. The reason being is that then the bulk of the code can get executed and then exit out early rather than having to go through a sort, and then it'd have to go through a sort and then it would have to go through a plot routine, which might not necessarily be optimal anyway for the order of the coordinates. And so anyway, this makes it a lot longer. As you see, there's hundreds, there's dozens of routines here, well, not dozens, but there's quite a few routines there to actually plot the different types of quadrilaterals. Wrong button. But I haven't actually got around to coding that yet because, well, time. It takes a long time to actually get to the point where I actually code the thing, because I'm still working out the original assignments. So this, so as I say, this is running on a Pi 3. It's triple buffered and running at fixed 25 per second with expanded landscape. Anyway, enjoy. Thank you for watching.